All right, guys, in this video, I'm going to go over pretty much everything we've been doing besides the factoring focused lesson. You are going to see some synthetic division. I should say dividing polynomials. You're going to see some synthetic division when they give us some information about a binomial factor that will help us kind of break this down. So it's just kind of a continuation of the stuff we've been doing with graphing and sketching polynomials, just a little bit more challenging each time, okay? But you're going to see a lot of the same stuff is still going on. So let's start with the degree and the leading coefficient. So this is already in standard form. My highest exponent is a 3. So degree is 3, which is odd. And my leading coefficient is in front of that. It's a positive 1. Right? The key thing is that it's positive. So when I sketch this right here on the side, my end behavior is going to look like this, where it's starting at the bottom left and going to the top right. Okay, so if we write it out, as x approaches negative infinity, our function values, our y values, are going to approach negative infinity as well. And as our x values approach positive infinity, our function or y values will approach positive infinity as well. Okay, to find the y-intercept, like we've done for a couple of lessons now, we're going to plug in 0. So I'm going to do 0 cubed plus 4 times 0 squared minus 11 times 0 minus 30. And what you'll notice is that all of these first terms are going to become 0. So your y-intercept is just going to be that minus 30. So 0 comma negative 30. All right, now let's get into how we need to find the zeros or x-intercepts, because we just don't know those yet. We're going to use this information at the beginning where it says x plus 5 is a factor. So think back to your lesson on synthetic division, where we had x minus a was our divisor, all right, which is in this case the x plus 5. So actually when you look at this plus 5, you need to think opposite, and we're going to be putting a negative 5 in the corner to use for our synthetic division. Then write down the coefficients from the original function. So that's 1, 4, negative 11, and negative 30. All right, so doing our synthetic division, bring down the 1, multiply by the number in the corner. We're going to add, repeat the process. And then here is going to be negative 6 times negative 5 is positive 30. And you should not be surprised that we got 0, right? When they tell you that x plus 5 is a factor, right, you can go ahead and guarantee that you're going to get 0 as the remainder. All right, so again, I've already started to factor this. X plus 5 is a factor. And these 3 coefficients right here are going to make up the next factor. So it's going to be x squared minus x minus 6. All right, so if I keep factoring, I'll keep going down here. I'm going to factor this quadratic trinomial here on the right-hand side using my x. So a times c, that adds to b. A is 1, c is negative 6, b is negative 1. So I need 2 numbers that multiply to give me negative 6 and add to a negative 1. So it's going to be negative 3 times 2 is negative 6. And negative 3 plus 2 is negative 1. So here's my fully factored function here, x plus 5, x minus 3, and x plus 2. All right, so if you wanted to put that f of x notation, there's the factored form. All right, so using our understanding of how to find the zeros or the x-intercepts, my zeros are going to be negative 5, positive 3, and negative 2. All right, so writing those down in my table from least to greatest, negative 5, 0, negative 2, 0, and positive 3, 0. And all of these are single roots, all right, that have a multiplicity of 1. So this is where the function is going to cross through at the x-axis. So I'm going to put, they all have a multiplicity of 1. They're single roots. So the description of the contact is going to be crosses through. And now you should have everything you need to make a sketch. Because this is a video and I can prepare before I start recording this video, I've gone ahead in Desmos and typed in this original function to see if there are any more points that I could plot. So I'll go ahead and show you that thing that I put in here. It's the one in red. So I'm going to use red as well on this graphing. So let's put down the x-intercepts, which is -5, 0, -2, 0, and 3, 0. My y-intercept is actually not able to be graphed. 0, -30 is off the grid. All right, we know my end behavior is going to be the bottom left to the top right. All right, so let's see if there are any more points we could plot based on this table. I see -4, 14, and -3, 12. So let's do those. -4, 14, and -3, 12. Okay, let's see if there's any others. Again, this is not, you do not have to do this. -1 and -16 is the only other one I could do. -1, -16. All right, so I'm gonna go ahead and make it now. And again, you don't have to do those other points, just the x-intercepts, the y-intercept if you can. In this case, we weren't able to do that. You might think, as I'm doing this, this looks a little different than how it looks when I showed you on Desmos. Again, I know that the y-intercept is further down. But the reason that it looks a little different on Desmos is because when you have those table of values, there's a little magnifying glass that you can click and it just changes the axes. All right, so that's why this looks a little bit different. But anyway, this is the first one here for number 1. Okay, let's go to number 2. Number 2. So on this one, we have a degree of 3 again, so still odd. Our leading coefficient this time is a +2, so not a +1. So in terms of the end behavior, same thing, bottom left to top right. Writing down my end behavior in terms of my x and my function. So as x values go to the left, my function is going to be going towards -infinity. And as the x values move to the right, my function is going to move towards +infinity. Okay, doing the same thing for the y-intercept that we did before. This time I have g of 0, which is going to be 2 times 0 cubed plus 5 times 0 squared minus 17 times 0 minus 20. Just like in the first one, all those terms that have the x value are going to become 0. So my y-intercept is just 0, comma, -20. So I'll just barely be able to plot that on this grid. Now, in terms of getting to fully factored, this time they've told us that x plus 4 is our factor. So using that same way that we did in number 1, I'm going to use division with the opposite of that. So -4 goes into that box in the corner. Using my coefficients 2, 5, -17, and -20, I'll be able to fully factor this. So bring down the 2 times -4 is -8. Add those together, you get -3. -3 times -4 is a +12. Add, you get -5, that's a +20. And again, you shouldn't be surprised that we get 0 there. So getting my factors now, I have x plus 4 already was a factor. And then remember, like we did before, these coefficients will make my other factor, 2x squared minus 3x minus 5. Now let's do some factoring of that quadratic trinomial. You'll notice this is not an a value of 1, so it's going to be a little more complicated, but we've done this a lot in the first semester. So a times c that adds to b, so that's 2 times -5, which is -10. b is -3, so I need two numbers that multiply to give me -10 and add to a -3. So I'm thinking -5 and 2. All right, that does work. So remember, because a is not 1, I'm going to take this middle piece and I'm going to blow it up or expand it with those two numbers. So I'm going to write 2x squared minus 5x, try that 5 again, There we go. Plus 2x minus 5. I'm going to factor by grouping. So I'm going to factor out x times 2x minus 5. And then factor out a 1. That leaves me with 2x minus 5. So bring down the x plus 1. The 2x minus 5 they share. And don't forget to bring down this original factor is x plus 4. So this is the fully factored g of x function. All right, the first two are pretty straightforward to find those. X-intercepts, you get -4. We already knew that one. -1. And this last one here, if I were to set that equal to 0, you could do it to the side if you wanted. You're going to move that -5 over with addition and then divide by 2 and you get 5/2. All right, or feel free to write it as 2.5, your choice. All right, so those are the x-intercepts. Again, all have a multiplicity of 1 and all are going to be single roots. So least to greatest, -4, 0, -1, 0, and 5/2, 0. So multiplicity of 1, they are single roots, which means they're all going to cross through when I graph this. Now, just like I did in number 1, before I started recording, I went ahead and typed this function into Desmos to see if there are any other points I could plot. I just to continue to remind you of this, that is not the expectation. That just helps me plot any extra ones. Let me make sure I know what color I had on Desmos. So I'm going to put the red one away, and we're going to use purple for this next one. All right, so purple, my x-intercepts of -4, -1, and then 2.5. And this, remember, the y-intercept is able to be plotted, 0, -20. So again, with my end behavior, I'm going to start at the bottom left and finish the top right. Okay, any other points? Let's see. I see -2 and +2, -2 is +18 and +2 is -18. So I'll plot those. So -2, 18. So way up here. And then +2, -18 down here. All right, and I'll go ahead and make my sketch. Again, if you have the y-intercept and the x-intercepts, then you are good to make the sketch. You don't need any other points. All right, I'm hoping that you see that a lot of this stuff is still the same from the last or the first couple of lessons of this unit. All right, just a little bit of a wrinkle where you had to actually do some algebra to find a factored form of this polynomial. Okay, so that's it for number 2. All right, that was a little bit more challenging, having to do a more difficult factoring of a quadratic trinomial. Let's try one more. Number 3. All right, so in number 3, all right, there is a little hint that we are going to use the quadratic formula. That's basically telling us that when we get to our quadratic, that's not going to be able to be factored. All right, so you're not always going to get that hint. All right, they're telling you here, which is great. So you don't have to waste the time to factor and realize that you cannot. But you can find out if you try on your own, like, oh man, I can't factor it. So then we're going to use the quadratic formula. A reminder again, like we mentioned in the first semester, I only do the quadratic formula if I can't figure out another way to solve it, right? It's kind of like my last resort. Okay, degree is 1. Nope, it's not. Just kidding. Degree is 3. Sorry about that. Which is odd. That's the same as the last two. There we go. Leading coefficient is 1, which is positive. So same end behavior, bottom left, top right. Same end behavior when I write it out. Our function is going to approach infinity as we move to the left. Excuse me, that's -infinity. Oh, struggling right now. Sorry, guys. Here we go. And then as we move to the right, our function is going to approach positive. There we go. The y-intercept, I'm going to go ahead and skip plugging in 0. I think we've done it enough times. You can see it's just going to be 0, 18, right? Which is not surprising because all the other values become 0. In terms of the division, again, seeing that x minus 2, I'm going to think opposite and put positive 2. So that's 1, negative 4, negative 5, and 18. I'm going to bring down the 1, multiply by the 2 to get 2, add, multiply, and we get 0. So my factors are x minus 2, right? That was the one they gave us at the beginning. And then x squared minus 2x minus 9. Okay, you can already see there are no factors of negative 9 that add to negative 2, right? Because I could use negative 9 and 1, change the signs, that doesn't work. Negative 3 and 3, that's not going to work either. So this is where it says to use a quadratic formula. I'm actually not going to use the quadratic formula. I'm going to use completing the square, but feel free to use the quadratic formula, right? This actually is fully factored for h of x, right? That is fully factored, but I'm going to solve this one using completing the square. So I'm going to move the minus 9 over to get 9. I'm going to add b over 2 squared. Negative 2 over 1. Negative 2 over 2 is negative 1. When you square that, you get positive 1. So this is x minus 1 squared equals 10. Take the square root of both sides, and you get x minus 1 equals plus or minus the square root of 10. So x equals 1 plus or minus the square root of 10. Now, whether you did this with completing the square or with the quadratic formula, it shouldn't matter. You should get the same thing. And I'm going to use my calculator to make sure that I get the decimal approximations here. So 1 minus the square root of 10 is going to be negative 2.16 approximately. So negative 2.16. And the other one, when you have 1 plus the square root of 10, is going to be approximately 4.16, okay? And the other one from my factored form gives us a value of x equals 2. So in order from least to greatest, negative 2.16, we have 2, 0, and then 4.16. Again, all of these are going to be single roots, multiplicity of 1. I'm going to go ahead and just copy this because it's all the same, just to save time on my video. All right, so those are all single roots. Now, when I plot this one, Desmos, I have the color blue. Did I have blue before? No, it's red. I'm going to use blue. Okay. So I'm going to do 0, 18. And my x-intercepts are negative 2.16, approximately there. Then positive 2 and 4.16. Y-intercept is already plotted. We have our end behavior going bottom left to top right. I'm going to see if I have any other. Looks like negative 2 comma 4 I'm going to use. Negative 2 comma 4. And then negative 1, 18. So it's the same as my y-intercept. And then 1 comma 10. I got a lot here. This is amazing. 1 comma 10. Again, none of this is necessary, guys. Just go ahead and make the sketch. And 3, negative 6. 4, negative 2. 3, negative 6. 3, negative 6. 4, negative 2. I think there was one more that I could do. 5, 18. Look at that. Amazing. Look at that. I already had it essentially there. All right, I'm going to make it now. All right, I hope as I finish this, you guys see kind of the process for how this is going to work in terms of kind of putting all this together. And I hope you're not surprised, but stuff that you did in the first semester is still going to be a part of this, right? It's not going anywhere. It always builds on itself. Okay, so that's it for number 3. Kind of show you the big picture here of finding all the stuff and then plotting it or sketching it. Okay, let's do 2 more and then I'll be done with this video. Very similar type questions, just no graphing or anything like that. It says find all the solutions to the following equation given that one of them is x equals 5. All right, so what I'm going to do is I'm going to get this in standard form first, get everything to one side, highest exponent to the lowest. Then I'm going to use synthetic division to find what's remaining, and then it says after you do that, the hint is to factor by grouping. So I'm hoping after I do that, I'm able to continue to factor. Okay, so let's leave the x to the 4th power where that is. Let's move the x cubed over. Same with the 14x squared. Leave the 36x alone and leave the 45 alone. So I'm going to put 5 in the corner. I'm going to have x, oh, no, I don't want that. I want the coefficients. So I want 1, -4, -14, 36, and 45. All right, so let's do that. 1 times 5 is 5. Add, you get 1. Add those together, you get -9. That's going to be -45. That's going to be -9. Multiply that, and you get -45, which adds to get 0. Again, you shouldn't be surprised. It does tell you that one of the solutions is 5. Okay. Now, you might be wondering, how come I didn't switch it to be -5? This one told us the solution is x equals 5, so I just wrote it in the corner. The first 3 told us that they were factors, and when you do that, you have to pull the opposite sign with it. So essentially what I'm doing here is, this is one of my solutions, so watch how I write that factor, thinking opposite, x minus that solution. Okay, these coefficients are going to give us the other factor, which is x cubed plus x squared minus 9x minus 9. It did say a hint of using grouping, so I'll go ahead and do grouping. Factor out x squared, you get x plus 1. Factor out minus 9, you get x plus 1. Keep going. That's x squared minus 9. Let's try that again. Times x plus 1. Bring down the x minus 5. We're not done yet, right? This is the difference of 2 squares, so my fully factored is going to be x minus 5, x plus 3, x minus 3, that's dots, and x plus 1. All of these are set equal to 0. We already know one of the solutions was 5. Now we know we have -3, +3, and -1. So all 4 of those are the solutions. Okay, that's it for number 4. Let's try number 5. Last one, then I'll be finished. Sorry, this is a little bit longer video. Okay. It says, hint, you'll need the quadratic formula. Maybe we'll need it. Maybe we'll be able to use the completing square again. That was nice. Okay, so we're told one of them is 1/2. I'm going to go ahead and put this in order again, all on the same side. So minus 13x squared plus 20x and then minus 7. I'm going to do 1/2 in the corner. So 2, -13, 20, and -7. Bring down the 2. Half of that is 1. You get -12. Half of that is -6. It's 14. Half of that is 7. You get 0. So that's going to be x minus 1/2 times 2x squared minus 12x plus 14. So now I'm going to focus on solving this one, right? And what I notice is that they all have a GCF of 2. So I'm going to go ahead and take out that 2, which is x squared minus 6x plus 7. I need factors of 7 that add to -6. Factors of 7. So 7 and 1 both positive doesn't work. 7 and 1 both negative doesn't work. So that's why they mentioned the quadratic formula. It's not factorable, but because I now have that 1 in front, I can go ahead and use completing the square. So x squared minus 6x, move the 7 over. I'm going to add b over 2 squared. So -6 over 2 is -3. Squared that is 9. So I get x minus 3 squared equals 2, or x minus 3 equals plus or minus the square root of 2. So my 2 solutions are going to be 3 plus the square root of 2 and 3 minus the square root of 2. So the solutions here that they want, we already know 1/2 was one of them. And then we also have 3 plus the square root of 2 and 3 minus the square root of 2. All right, so that is going to be our 3 solutions for number 5. All right, check out the homework. Come see if you have any questions. Good luck.